Hi everyone. Today, so it's Adam again. Today we're going to go over indices and logarithms. Okay. So first of all, the laws of indices. So these are all in your log tables, but this is one of the things that you need to have practice with it to be able to do it. Okay. It's simply too difficult. If you haven't done it before. Okay, so these are different laws. All right, so you've a to the power p multiplied by a to the power q. This is a to the power of p plus q. So when multiplying like this, you add the powers. All right, a to the power of p divided by a to the power of q. This becomes minusing, so it's a to the power of p minus q. Okay, a to the power of p all to the power of q. You now multiply the powers, so it's a to the power of p times q, like that. Okay, a to the power of 0, this is equal to 1, so long as a is not equal to 0. So a can be anything, just not 0 in this case. Okay, so now I'll just do a quick example of these four, where they are before I go on to any more. So if I asked you what a multiplied by a was, you would just say, oh, that's a squared. Well, this is a to the power of 1 and a to the power of 1. So under the first rule, we add. So 1 plus 1 is 2. Okay? Same thing, if I did a squared divided by a, that's obviously equal to a to the power of 1. Okay? So here we just have 2 minus 1 is 1. A squared, that's equal to a squared times a squared. Okay, sorry, this is a really bad example. Cubed. Cubed and cubed. The reason I'm changing the 2 to 3 is specifically because I was going to say you're obviously multiplying, but you don't know that because 2 times 2 is 4 and 2 plus 2 is 4. That's why I've changed it to a 3. So this is equal to, again, you add the powers, so it's a to the power of 6. So here you multiply because 3 times 2 is 6 and 3 plus 2 is 5. And because you get a to the power of 6, that means you must multiply. Okay? This is the exact same thing as to if you were to do a squared cubed, because that's equal to a squared times a squared times a squared. Again, you just add the powers, 2 plus 2 plus 2, so it's a to the power of 2 plus 2 plus 2, which is a to the power of 6. Okay? And the very last one, a to the power of 0. A to the power of 0, that's equal to a divided by a. Because again, that's equal to a to the power of 1 minus 1. So that's why this is always equal to 1, because it's a divided by a. The only time this works is when, this doesn't work is when a is 0, because I can't divide by 0. Okay? So hopefully that's all okay. The next law then is a to the power of 1 over q is the cube root of a. The main thing here, sorry, I might just, I'll leave it for a second. So this, I'll do an example in a second. It's just, that's kind of like if you have a to the power of a half multiplied by a to the power of a half, that's equal to a. So it's a to the power of a half squared is equal to a. So therefore a to the power of a half is the square root of a. So that's where you get this rule from. Okay, so if it's a to the power of a half, it's just a square root. That's the most important one. That's the most common one. So just have in your head that if you have a to the power of a half, that's just the square root. Okay. A to the power of p over q, that's just equal to the cube root of a to the power of p. And it's also equal to the cube root of a all to the power of p. So this just stems from this rule up here, where you can do this is equal to this. Okay, so you can kind of flip the powers. So it's the same thing here. You can do to the power of p first and then do the cube root of the whole thing, or you can do the cube root first and then raise the whole thing to the power of p. So your order doesn't matter. Okay. A to the power of minus p, that's equal to 1 over a to the p. The reason is a to the minus p, that's a to the power of 0 divided by a to the power of p. So that's just 1 over a to the power of p. Again, this is for a not equal to 0. Okay? Then you have ab to the power of p. That's equal to a to the power of p multiplied by b to the power of p. So an example of this would basically be the square root of 2x. That's the square root of 2 times the square root of x. So basically, if you have the same power, because remember, this is 2x to the power of a half. Okay? Sorry, I might just move that over here instead. So like that. Okay? And very last one, it's the same thing. A over b to the power of p is just a to the power of p divided by b to the power of p. That's all. Okay. So that's all fine. So that's just when you're doing algebra, those are your laws of indices. Okay. I'll do a couple of examples. So it says something like this. Yeah, I'm going to do a couple of easy ones and then I'll go to the hard ones. So it says, so I can probably do all these parts in one line. Okay. So for the first part, it's a to the power of 7 divided by a to the power of 2. Here you minus powers, so that's a to the power of 5. So 7 minus 2. Okay. A to the power of 7 multiplied by a squared. Here you add powers, so it's a to the power of 9. Sorry. Part 3, it says a to the power of 7 squared. So here you multiply the powers. But again, if you forget, you can always use other rules of indices. If you forget, so you should multiply. So this is a to the power of 14. But let's say you forget. A to the power of 7 squared, that's a to the power of 7 multiplied by a to the power of 7. Here I add the powers, so I get a to the power of 14. Okay? But if you multiplied 7 by 2, you would have gotten the same answer. The square root of a, that's equal to a to the power of a half. Like that. Okay? And the next part is the square root of a to the power of 7. That's just a to the power of 7 all to the power of a half. And again, here you just multiply powers. Sorry. So it's just multiply powers. So it's a to the power of 7 over 2. Like that. 1 over a cubed. That's just a to the negative 3. Okay? And then 1 over root a. That's equal to 1 over a to the power of a half. And that's a to the minus 1 half. Just like that. So hopefully that's okay. All right. Now I'm going to do another one. This is a very, very hard question. All right. So yeah, just be a little bit prepared that this is not going to be one bit easy at all. Okay. So what we have is, it says find k if you have the square root of e to the 8 plus e to the 4, e cubed minus 1, all over e to the power of 8 minus 1, e squared plus e plus 1 equals e to the power of k all over the square root of e to the k plus 1. Sorry, that plus 1 is down below. So that's like this, sorry, times e plus 1. Okay, so the very first thing that I'm going to do is I'm going to square both sides to get rid of the square roots. So if I square the left-hand side, so remember, okay, just say this thing is, I don't know, a, just because I can't be bothered writing it again. The square root of a, that's a to the power of a half. So if I square it, I basically get rid of the square root. Okay, so if I square the left-hand side, I get e to the 8 plus e to the 4, e cubed minus 1, all over e to the 8 minus 1, e squared plus e plus 1, equals. If I square this, I get e to the k squared, and on the bottom, the square root just disappears. So it's e to the k plus 1, e plus 1. Okay? So now, the next thing that I want to do is this here is a difference of 2 cubes. So hopefully you remember that a cubed minus b cubed, that's equal to a minus b times a squared plus ab plus b squared. So now I can replace that with e to the 8 plus e to the 4 times e minus 1, e squared plus e plus 1 all over e to the 8 minus 1, e squared plus e plus 1. And that's again equal to e to the power. So here you can multiply powers. So it's e to the power of 2k all over e to the k plus 1 times e plus 1. Like that. Okay. So now this cancels with this. Now, again, I can do more simplifications. So on the top, I can factor out an e to the 4. So it's e to the 4 into e to the 4 plus 1. So I factor out an e to the 4. So I'm taking out an e to the 4 out of this guy. If I divide by e to the 4, I do 8 minus 4, which is e to the 4. And I do e to the 4, 4 minus 4 is 0. E to the power of 0 is 1. Because remember, e is just 2, e is just a number. Sorry, I probably should have said that e is just equal to 2.72. But sorry, it's 2.718. On and on. So again, e is just a number. So you get this times e minus 1. The bottom, that's a difference of 2 squares. So that's e to the power of 4 minus 1, e to the power of 4 plus 1. So again, these two things cancel. Okay? So now, what I'm going to do is, now I'm going to say, okay, the bottom thing is going to simplify even further. This is equal to e to the power of 4, e minus 1, all over. That's another difference of 2 squares. So it's e squared minus 1, e squared plus 1. And again, that simplifies down even further to e plus 1, e minus 1, e squared plus 1. Because again, this is another difference of 2 squares. Okay. And now this will cancel with this. And this is equal to e to the 2k over e to the k plus 1 e plus 1. So now both sides are divided by e plus 1, so I can simply get rid of them. Okay? So I'm left with e to the 4 all over e to the 2 plus 1 is equal to e to the 2k all over e to the k plus 1. Sorry, that is incorrect again. That should be a plus 1 down here. So I'm left with this. Now, just by looking at the left and the right, you can see that this thing has to be equal to this, and this has to be equal to this. So therefore, k has to equal 2. Okay, so that was really, really involved. All right. So if you didn't get that, don't worry. But that I just wanted to go through one hard example just to say that I had done a difficult one. Okay. All right. So now I'm just going to finish this before I move on to logs, and then I'll make logs its own video. Okay. So the next thing they might ask you to do, they might say solve 4 to the x equals 8 over root 2. So just solve for x. So what value of x will give you this, okay? So first of all, whenever you get something like this, you always want to change the numbers to be the same thing. So here I have that 2 is equal to 2. 4 I know is equal to 2 squared, so 2 times 2 is 4, and I know that 2 cubed is equal to 8. So the very first thing that I want to do, I want to change every single number to the same base number. So I'm going to get rid of the 4 and the 8 and change them all to 2's. So it's 2 squared to the power of x is equal to 2 cubed divided by root 2. So 2 cubed divided by the square root, that's 2 to the power of a half, remember? So now, on the left-hand side, we have 2 squared all to the power of x. Here, you multiply powers. So it's 2 to the power of 2x. On the right-hand side, you can minus powers. 3 minus a half, that's 2.5. Okay? So now what we have is, we have on the left-hand side, we have 2 to the power of 2x, and on the right-hand side, we have 2 to the power of 2.5. What that basically tells us, that means that because the base numbers are the same, the exponents, so that's what they're called, the powers have to be the same. So 2x has to be equal to 2.5, and therefore x has to be equal to 1.25. Like that. So that's how you do those ones. So, and again, it would have been the exact same thing if it was like 9 to the power of x equals 27 over root 3. You would say, oh, well, 9 is equal to 3 squared. 27 is equal to 3 cubed. And you would just work on like that. Okay? So you always change it to the smaller number. Okay, so hopefully that's all right. There's just one more thing that I want to do before I end this video. And it is something like this. So if you have 3 to the power of 2x plus 1 minus 28 3 to the x plus 9 equals 0. How do you solve something like this? Well, the very first thing that you would do is this 3 to the power of 2x plus 1 looks a little bit ugly. So I'm going to change it. So that's 3 to the power of 1 multiplied by 3 to the power of 2x. Equals 0, okay? Remember, that's 3 multiplied by 3 to the x squared. So 3 to the 2x, that's just 3 squared to the power of x, but it's also 3 to the power of x all to the power of 2. Because remember, you multiply these powers. Okay? Minus 28 times 3 to the x plus 9 equals 0. Now, some of you may have spotted it, but this is simply a quadratic. Okay, so what I can do is I can let 3 to the power of x equal y, like this, okay? This means that 3y squared minus 28y plus 9 equals 0. So now I just want to solve this like usual. So this now, I can use either the minus b formula or I can factorize. I'm going to factorize because it's a little bit faster. The minus 9 is down here and the minus 1 is up here. So remember, if this is plus, the sign of these two things are the same. This is negative, which means both of them have to be negative. Okay, just in case you're wondering how I got this. So this means it's 3y minus 1, y minus 9 equals 0. And therefore, either this equals 0 or that does. So if 3y minus 1 equals 0, then 3y equals 1, so y equals a third. Or we can have that y minus 9 equals 0, and therefore y equals 9. Now remember, y is equal to 3x, and it's x we're looking to solve. So you would say, okay, that means that 3 to the power of x equals 1 over 3, or 3 to the power of x equals 9. 3 to the power of x equals 1/3. This is x equals minus 1. Because remember, minus basically means it's 1 over. So because it's 1/3, it just means that it's x to the power of minus 1. Okay? And we saw a second ago that 3 squared was equal to 9. So those are your two answers. Okay? All right. I'll do one more because I think there's one more thing that can trip people up, and it's something like this. So if you have 2 to the power of x plus 2 squared minus x equals 5. So believe it or not, this is again a quadratic, okay? So what you do here is you would say, okay, this is 2 to the power of x plus, this is 2 squared divided by 2 to the power of x. That's where the minus comes from up here, okay? And that equals 5. So now this is 2 to the power of x plus 4 over 2 to the power of x equals 5. So now I can multiply everything by 2 to the x. Or, you know, first I'll say let 2 to the x equal y. So it's y plus 4 over y equals 5. So now I can multiply everything by y and get y squared plus 4 equals 5y. So y squared minus 5y plus 4 equals 0. So you get that y and y. Again, this is plus, which means the sign of these are the same. This is minus, and therefore both of them have to be minus. So this is just 4 and 1. So you get that y minus 4 times y minus 1 equals 0. So either y has to equal 4 or y has to equal 1. So again, y is equal to 2 to the x. So either 2 to the x equals 4 or 2 to the x equals 1. So we saw a while ago that 2 squared would equal 4. And then the other one, then you have is 2 to the power of x equals 1. Remember, anything to the power of 0 is always 1. So in this case, x would equal 0. Okay? So that is how you do that. Now, whenever you have to multiply by something to the power of x here, so like this one, you had to multiply by 2 to the power of x, just be careful that both of these are solutions, okay? In this case, they are, but they mightn't be, okay? So just be careful. You might get one that isn't a solution. Like you might get like 2 to the power of x has to be equal to minus 5. That can never be true because 2 to the power of x is always greater than 0. So if you do get something like this, and you get two answers here, if one of them happens to be minus, don't worry, because you mightn't always get two answers. Here you do, but you mightn't always. There mightn't always be two answers, and there might just be one answer. So just be careful with that, okay? And please don't panic if if it does happen to be like that. Okay. Sorry, the very last thing that I want to go over is just surds and irrational numbers. So they might ask you to leave your answer in surd form. Surd form is basically just leave it in terms of square roots. That's all. So it could be something like root 5 plus 2 root 2 times root 5 minus root 2. So multiply this and leave it in surd form. So multiply, so remember your multiplication is this times this and this times this. So root 5 times root 5, that's 5. Root 5 minus root 2, that's minus root 10. So remember, because there's square roots on both of them, I can just say 5 times 2 is 10 and then square root 10. Okay? Then this multiplied by this and this multiplied by this. So 2 root 2 times root 5, that's plus 2 root 10. 2 root 2 minus root 2. Root 2 times root 2 is 2. And then 2 times 2 is 4, so it's minus 4. So 5 minus 4, that's 1. Minus root 10 plus 2 root 10, that's plus root 10. And this is in surd form. Okay, so this, if you plug it in your calculator, you get 3 point something. Probably 3.1, whatever. But basically, if you plug that into your calculator, you get a decimal. That's not surd form. Surd form is specifically this. Okay, so just to be clear. All right, that's the end of that. The next part will be logarithms, which I will cover in the next video. So thank you very much for paying attention, and I'll see you in the next one.